Hello everyone, welcome back to my channel. So in this video we are going to learn about Newton Raphson method. Okay, so Newton Raphson method. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So Newton Raphson method, we'll learn some of the important points regarding this. It is also called Newton Raphson method is also called tangent method. Okay, some of the important points which we require for writing the GATE exam we have to read. And so this method, that is Newton Raphson method, depends or it is more sensitive. Okay, so it depends or it is more sensitive to initial value. That means if you choose the initial value correctly, so if you choose this initial value correctly, so if you choose this value correctly, then it will gives you the output. So it gives the output perfectly. Okay, it is more sensitive to initial value. And more important point here is order of convergence. So order of convergence in Newton Raphson method is second order. That means it converges faster rate of convergence. Okay, so it converges very fast. Right, as we know, Newton Raphson method is an example of extrapolation method. Okay, so it is an example of extrapolation method. So I have told you about this extrapolation method in my previous video. You can watch that also. So extrapolation method, or it is also called as open-end method. Okay, so it is also called as open-end method. So in extrapolation method or open-end method, we will take only one initial estimate. Okay, so we'll take only one initial estimate. So one initial estimate is considered and we are going to find the successive approximations based on the algorithm, that is algorithm of Newton Raphson method. We are going to find the successive approximations. So when will be the iteration stops? So these successive approximations we are going to find successively, so one after the other. So initial estimate will take one value and we'll get the first approximation, second approximation, third approximation based on the formula. I'll tell you the formula now. Okay, so based on that you'll have successive approximations. When will this iterative method stops? So iterative method stops when two successive approximations are almost same. Okay, so when two successive approximations are almost same, then iteration stops. Right, so the iterative method or the successive approximations of Newton Raphson method is found out by using the formula xi plus 1 is equal to xi minus f of xi by f dash of xi. Okay, only this formula you have to remember. Some of the important points which I have discussed here. So rate of convergence is faster, order of convergence is second order. It is an example of extrapolation method or open-end method. Only one initial estimate is taken. Okay, and successive approximation stops when two successive approximations are almost same. okay, within the permissible error value. Within the permissible error value if they are having, so we can stop the iteration there. Okay, so this is the methodology of solving any Newton Raphson method problem. Okay, so this is the iteration method formula, xi plus 1, where this xi is the initial estimate or previous estimate, initial estimate, or when you are finding second estimate, it will be the first estimate, that is previous estimate. When you are finding the first estimate, it will be initial estimate. Okay, so when you are finding the first estimate, it will be initial estimate, xi will be initial estimate, and xi plus 1 will be first estimate. And similarly, when you are finding second estimate, xi will be the previous estimate, that is the first estimate, and xi plus 1 will be the second estimate, and so on. Okay, so this is the methodology to find the Newton Raphson method. Okay, so now we are going to solve different cases. Okay, so different cases where Newton Raphson method can be used. Okay, so as a part of that, we are going to consider 4 cases, out of which I am dealing with the first case now, to find the square root of a number. Okay, so in GATE exam you may get directly the formula, or you may get questions based on this. So when you are getting a question based on finding the square root of number, so again solving them is difficult, so that so it is time taking process, solving for the formula and then substituting the value, so it takes more time. So I'll derive the formula here now. So learn the concept how to derive the formula, and remember that as a formula, so that you can apply directly in the examination. Okay, so finding the square root of a number, so they may give you like some previous question I'm giving here. So find the second estimate or first estimate of this equation. They will give like this: x square minus 117 is equal to 0. So this question I will solve in my next video. Okay, so x square minus 117 is equal to 0. So such type of questions will be given. So this becomes x square is equal to 117. So x square is equal to 117 and x is equal to root of 117. So which is a square root of the number. Okay, so all such problems can be solved by this method. Okay, so I'll derive the formula now, and then you can remember only the final result. Okay, so in order to explain you the concept and deriving the formula now, so let n be the number. Let n be the number for which we are going to find the square root. Okay, let n be the number for which we are going to find the square root, and let the square root be square root of n be x. Okay, let that square root of n be x, that is x is equal to square root of n. Okay, so it becomes now x square is equal to n, squaring on both sides, you will get x square is equal to n, and similarly x square minus n is equal to 0. X square minus n is equal to 0. Let this be f of x. Let this be f of x. Therefore f of x is equal to x square minus n. Okay, so we know that from the Newton Raphson method, the iterative formula is given by xi minus f of xi divided by f dash of xi. Okay, so we need f dash of xi. So f of xi we know, so in the place of x we are substituting with xi, so xi square minus n. So what is f dash of xi then? It will be differentiation of this, so it will be 2xi. Differentiation of xi square is 2xi. Okay, so xi plus 1 is equal to xi minus, what is f of xi? F of xi is this one, xi square minus n. Xi square minus n, okay, divided by f dash of xi is 2xi, so this will be 2xi. So xi plus 1 is equal to, so taking LCM, so it will become 2xi square, so multiplying this, minus xi square plus n divided by 2xi. So this becomes xi square, so 2xi square minus xi square will become xi square plus n divided by 2xi. Okay, so I am taking this 2 outside, so 1 by 2. So now this becomes xi square plus n by xi. So final equation is xi plus 1 is equal to 1 by 2 into xi square divided by xi is xi plus n by xi. N by xi. So this is the simple equation. So if you can remember this formula, you can directly substitute in this see this type of problems. N value is equal to 117. So just substitute this n value here and you will get the answer directly. Okay, you'll get the next estimate very easily. Okay, so remember this formula. Okay, and this is the procedure how to solve for this. This is the procedure. Okay. So now we'll see the second case, that is case 2. Case 2, to find the inverse of square root of a number. Okay, so inverse of square root of a number. Okay, let n be the number which we want to find the inverse of the square root. Let n be the number. Okay, so and x be the inverse of square root of n. Okay, let x be this. Okay, so that means it becomes x is equal to 1 by root n and x square is equal to 1 by n. So this implies x square minus 1 by n is equal to 0. This will take it as f of x. So f of x is equal to x square minus 1 by n. And we know the iterative formula, xi plus 1 is equal to xi minus f of xi divided by f dash of xi. Okay, so f of xi is given by xi square minus 1 by n, and similarly f dash of xi is differentiation of this. So xi square differentiation is 2xi, 1 by n is a constant, so its differentiation is 0. So you'll get 0 here. So what will be xi plus 1 then? Xi plus 1 is equal to xi minus f of xi. F of xi is this one, xi whole square, xi square minus 1 by n divided by 2xi. So xi plus 1 is equal to, so taking LCM you'll get 2xi square minus xi square plus 1 by n. Minus into minus becomes plus here, divided by 2xi. So 1 by 2 I am taking common. So 1 by 2 denominator only I am taking common. So 2xi square minus xi square will become xi square plus 1 by n divided by xi. Okay, so the final equation xi plus 1 is equal to 1 by 2 into, so xi square divided by xi is xi plus 1 by n. So 1 by n into xi is 1 by n into xi. Okay, so this is the formula which you have to remember, right? So let n be the number. So they may give you like this. So in the previous case only, so x square minus 1 by 117 is equal to 0. So in this case you can just substitute n value as 117 so that you can get the next iterations very easily. Okay, so next we will discuss about case 3. Okay, so case 3 is finding reciprocal of a number. Reciprocal of a number. Okay, so they may give you to find x is equal to 1 by 49 or anything. Okay, so reciprocal of a number, like let it be any number. So they may give you this and they may ask you to find first estimate or second estimate. Okay, so directly you can apply the formula. If you derive the formula here and remember the formula, remember the final result which we are getting now, so you can directly apply 49 in the place of n. Okay, so let n be the number. Okay, let n be the number for which we want to find the reciprocal. Okay, and x be its reciprocal. Okay, so let x be its reciprocal, that is x is equal to 1 by n, or we also can write as n is equal to 1 by x, and n is equal to 1 by x. So this, from this what can we write? 1 by x minus n is equal to 0. 1 by x minus n is equal to 0. So this we are taking it as f of x. Okay, so now we have got f of x is equal to 1 by x minus n, and we have the iteration formula xi plus 1 is equal to xi minus f of xi divided by f dash of xi. Okay, so we have f of xi is equal to 1 by xi minus n, and f dash of xi, we have to find. So 1 by d by dx of 1 by x is minus 1 by x square, so 1 minus 1 by xi square, and differentiation of a constant, n is a constant which is a number, so differentiation of constant is 0. So this is the value of f of x, f dash of xi. So the iteration formula is given by xi minus f of xi. F of xi is this one, 1 by xi minus n divided by minus 1 by xi square, minus 1 by xi square. So this minus and this minus will get cancelled off, so it becomes plus. Okay, so it becomes now xi plus 1 by xi minus n divided by 1 by xi square, 1 by xi square. Right, so xi plus 1 is equal to xi plus 1 by xi minus n. So this 1 by x square, if you take it to numerator, it becomes xi square. So this becomes now xi plus 1 by xi multiplied by xi square will become again xi minus n xi square. So n into xi square will become n xi square. So xi plus 1 is equal to xi plus xi is 2xi minus n into xi square. So the final relationship or final formula for this is xi plus 1 is equal to, take xi common, so it will be 2 minus n into xi. Okay, so this is the formula which you have to remember for the case 3, that is finding the reciprocal of a number. Okay, so for these type of examples, finding the x is equal to 114, x is equal to 114, x is equal to 1 by 49, or x minus 149 is equal to 0. If they give, directly substitute in the place of n by 49. Okay, so now we'll see the case 4. So case 4, which is the last case, is finding the cube root of a number. Cube root of a number. Okay, so same, let n be the number. Okay, so let n be the number for which we want to find the cubed root, and x be the cubed root of n. Cubed root of n. Okay, so that means x is equal to cubed root of n. Okay, so cubing on both sides, what you'll get is x cube is equal to n. So from this, what can we write is x cube minus n is equal to 0. So this is now our f of x. So f of x, we have got it as x cube minus n. Similarly, f of xi is xi cube minus n. So f dash of xi is d by dx of this. So d by dx of x cube is 3x square. So 3xi square is the differentiation, and differentiation of n, which is a constant, is 0. So this is your f dash of xi, and we have the iteration formula by Newton Raphson method is xi minus f of xi by f dash of xi. So xi plus 1 is equal to xi minus f of xi. F of xi is this one, xi cube minus n, divided by f dash of xi is 3xi square. Okay, so taking LCM, so multiplying this with this, 3xi square into xi becomes 3xi cube minus xi cube plus n. Okay, so minus into minus becomes plus, divided by 3xi square. Okay, so this 3xi cube minus xi cube is 2xi cube plus n divided by 3xi square. 3xi square, right? So the final formula here is xi plus 1 is equal to, take this 3 outside, 1 by 3 into, so this becomes now 2xi cube divided by xi square plus n by xi square. So xi plus 1 is equal to 1 by 3 into 2xi plus n by xi square. Okay, so this is the formula. This is the formula which you have to remember for finding the cubed root of a number. Okay, so if you are given with finding x is equal x minus cubed root of something like 34 or 36. Okay, so find the first estimate or second estimate, they may give any value. So here n value is equal to 34. For such type of questions, n is equal to 34. Okay, so just substitute the n value in this equation, you will get the either first estimate or second estimate, whatever you want, you can find by using this iterative method formula. Okay, so I'll write just as a summary of Newton Raphson method, summary of all the formulas here. So the basic formula, the first one is basic formula or basic iterative formula. Okay, so basic iterative formula is xi plus 1 is equal to xi minus f of xi divided by f dash of xi. Okay, so the condition here is f dash of xy should not be equal to 0. F dash of xi should not be equal to 0. Second, for the square root, so f of x is equal to square root of n. Okay, so f of x is equal to square root of n. So in this condition, the formula is xi plus 1 is equal to 1 by 2 into xi plus n by xi. Okay, so just remember this formula. Third function is inverse of square root. F of xi is equal to 1 by square root of n. For this, xi plus 1 is equal to 1 by 2 into xi plus 1 by n into xi. Okay, so this is the formula. Next, fourth, for finding the inverse of a number, f of x is equal to 1 by n. For such type of problems, the iterative formula is given by xi plus 1 is equal to xi into 2 minus n into xi. Okay, so just remember this formula. Last one, for f of x is equal to cubed root of n. Cubed root of n, it is xi plus 1 is equal to 1 by 3 into 2xi plus n by xi square. Okay, so this is the formula. Okay, so you just remember these formulas Okay, I have solved also these in the previous slides, or you can just remember these formulas, you can apply there in the exam and you can get the directly answers. They may ask you to find the first estimate or a second estimate. For any estimate you can find this using these formulas of Newton Raphson method. Okay.